So let's look at this one right here. This is a YD, all right? And if you've noticed, I haven't used the square root of 3 on any of these numbers yet, okay? There's only one time when you really need to start pulling out stuff and it gets a little squirrely. That's if you don't have this neutral, and then you have to do a phase-to-phase value on the Y, all right? So let's look at this one right here. I already did this on a previous video. It's going to be, this is a YN with a delta 1, okay? Put that in your TTR to calculate it right. And then what are we looking at as far as ratio? Well, the the Y it has a neutral brought out. So we're going to inject on that neutral and H1, okay? So that's going to induce down here and onto our neutral. This is our common neutral, and then H1 is right here. So it's this coil, okay? Oh, look at that. X1 connects to these right here. So our A phase connects to X1 and X2. Is that what it looks like right here? Well, yeah, this line is parallel with this line. And H1, X1 to X2. So everything, like I was saying earlier, lines up. And this is a phase to ground voltage, and this is a phase to phase voltage. So what are our numbers? Primary phase to ground is going to be 7,200 volts divided by, what's our phase to phase voltage on the secondary? 240. So 240, do the math on that, 7,200 divided by 240, and you get exactly 30. Look how easy that math is. No square root of 3 required. Just use the induced coil voltages, okay? Identify phase voltage to phase voltage. That's all you have to do. And it's a trick, like I said, it's the parallel lines. Okay, that tells you exactly how this transformer is connected. That's why engineers came up with this vector group diagram. Okay, we can get our clock shift. We can get exactly what our connections are. We don't have to draw this giant connection diagram. All we have to do is a triangle and a Y. Okay, super easy. That's what they're there for. So I got one more right here, and this is what we're going to look at is what's our primary voltage? Well, we have a de-energized tap changer on the primary, and depending on how you test it, right, what are you connected to? You have to identify this. So we're just going to use the nominal tap, the middle one right here, and we're just going to say that it's tap 3, and then we're also going to use the neutral tap, so on the load tap changer, so you've got plenty of voltages there. So now that we have that, what is going? We don't. Look, there's probably part of this nameplate that I'm not showing, but we could calculate it if it's not there. So we have a delta on the primary and a Y on the secondary. This right here, if you look at this, this is going to be a DYN1, all back again, okay? And then what is our voltages? Well, the delta is going to be 67,275, and our Y is well, you got to be careful. This is talking about phase to phase voltage. Okay, so this is a 23,900. So let's do some quick math right here. 23,900 divided by the square root of 3. Why are we doing that? We want a phase to ground voltage. Okay, so this is one reason why you would do this. 23,900 divided by the square root of 3 is going to be 13,798.67 volts. Okay, now what you could do is you could go ahead and say, well, I want to divide this by 13,798 volts, right? 0.67. Well, you could do that. Another way that you could write this, because I like easier math, is I'm going to write it over here on the left, is 67,275 divided by, and we're just going to take this and substitute it in. Well, if you leave this on the bottom, we're going to take this and put a 1, and then we're going to put multiplied. Well, if you divide, you're always multiplying by the inverse. So we're going to do 23,900 and then the square root of 3. Remember, the square root of 3 was on the opposite side of this fraction, right? So let's keep it over here. So that means it becomes on the top now. And I promise you, you're going to get the same number if you put this into your calculator. And I'm going to divide this one out real quick. This is going to be, and this one is going to be 4.8 0.8754. Okay, that's your ratio. And if you go ahead and do the math, which you'll get this number right here. This is going to be 100 and some thousand, I believe. And then you're going to divide this out, and again, you're going to get 4.8754. It's the same number. This is why you would use a square root of 3, is because you're only given phase-to-phase voltages. Another indication or another reason why you would use a square root of 3 is because if you look at your vector group, they're not bringing a neutral out. Okay, so that means that you have to use, because you have a Y here, you know it's inducing this coil onto this coil and then this coil onto this coil. Well, you've got two phases here, and so, but you're only measuring across one here. So how do you do that? Well, you have to end up using the square root of 3 in order to get that, because you just don't have the neutral there. Okay, so that's why you would use the square root of 3. And there are plenty of great references. I'm going to pull one up right now. So this is a reference that I've found. I think this might come from the AEMC website, where it explains how to use single-phase transformer or TTRs in order to test three-phase transformers, which is perfectly acceptable. But the only thing is the way that it's written here, you kind of have to be careful with a couple things, because, for example, this is like a YND1, and what they don't tell you specifically is that you're using, and look, this is the same calculation I showed you earlier. The square root of 3 is on the top. What they don't tell you is that these are supposed to be your phase-to-phase voltages. So they don't say that explicitly in here. Maybe there's a page missing in my set right here that goes over that. But I just want to be clear that this is using line voltages, phase to phase, not phase to ground, even though this is a YN transformer. But there are plenty of pages in this book, and it's got so many different types of connections that you can go over. So I recommend getting your hands on something like this. I mean, it's even got some of these crazy zigzags in here and how to test them. It tells you exactly how to make each connection phase to phase. So hopefully this helps someone. And if you got any questions, let's see them down in the comments. I'm sure you got something.